Okay, so this is the last example that we're going to do in chapter 4. So example 9. A nutritionist believes that there is a positive correlation between the total amount of fat in grams and the total amount of cholesterol in milligrams in a fast food item. She randomly selects 15 items from a fast food menu and records the following sample data. So on top, I just have the item number 1, 2, 3, all the way to the 15th item. So that's not part of the variable. The variables, right, are fat and cholesterol. So fat is listed in the middle row and cholesterol is the bottom row. And typically, right, the cholesterol content tends to depend on fat content, right? And the higher the amount of fat, more likely it's going to have more cholesterol, right? So we're going to let X be the independent variable, fat, and then Y will be the dependent variable, and that'll be cholesterol. So I'm thinking there's going to be a positive correlation, just like the nutritionist believes, right? That there's going to be a positive correlation between the two variables. So why don't we confirm this by constructing a scatter diagram? So that's what we're going to do first in part A. And just like we've done before, you have to enter your X variables into a list and then your Y variable into a list. So you guys can pause here, take a minute, enter your data values into your calculator. And I'm just going to make a note that I put my fat content in list 3, and then list 4, I put the cholesterol. And you guys can feel free to put these data values in whatever list you like. So I'm going to go into my calculator and I'm going to go into stat plot because we want to plot the relationship first, right? We want to look at the scatter diagram. So we're going to press, actually before we do, don't forget, every time you go to do a new scatter diagram, just make sure you go into Y equals and you clear out whatever model you had from the previous question. So this was from the bare data, so let's just clear it out. All right, so now we could go into stat plot. So we're going to press second and then Y equals. I'm going to choose plot 1. It's on, arrow down, make sure we're choosing scatter plot, and then put your X list and your Y list. So my X list is L3 this time, and my Y list is L4. And then I'm going to leave the mark. And then we have to press graph. And you see how tiny this plot looks? So remember, we're always safe if we press zoom and then option 9, zoom stat. So let's press zoom and then press option 9. And now it's going to adjust the window so that we have a more clear picture. And we definitely see a positive linear correlation, right? So we could confirm that there's a positive linear correlation between the amount of fat in an item and the amount of cholesterol. So that was part A. So now part B says calculate the sample correlation coefficient R. And remember, the correlation coefficient R measures the strength of the linear relationship. Now we determined with the scatter diagram that there's a positive linear correlation, so we should get a positive R value. So let's go back to the calculator. And to get the R value, we press stat. We arrow over to calc, and it's going to be option 8. You don't have to scroll down to 8. You could just press option 8, the linear reg A plus BX. Tell the calculator the X list, mine is L3, your Y list, mine was L4, and we leave everything else blank. We just want to go to calculate. And there's my output, right? It gives us the linear regression coefficients A and B. We have R squared and we have R. So right now we're looking for R. And let's round 3 decimal places this time. Really, it just depends when you're doing the homework in MyStatLab, it'll tell you how many places to round. So let's just round 3, just to make sure everybody's comfortable rounding 3 places. So if we round R to 3 places, it's going to be 0.809. So R is equal to 0.809, which is close to 1, right? It's up there. So that's a moderate to moderate strong positive linear relationship. So part C, let's calculate the coefficient of determination, which is R squared, and we'll interpret it. So let's go back to the output. We have R squared right there. R squared is equal to about 0.65. Let's go 2 places this time since we typically convert it to a percent. So R squared is 0.65. Or 65%. Now, the coefficient of determination R squared, that tells us the percent of the variance in the dependent variable that could be accounted for by the variance in the independent variable. So let's put that in context in this problem. So we could say that 65% of the variance in cholesterol can be accounted for by the variance in the amount of fat. So we can say that 65% of the variance in the cholesterol can be accounted for by the variance in the amount of fat. So now what I want to do in part D is let's get the regression equation. So let's come up with the equation that's going to be the best fit for this data. Now, we also have that in the output that we already pulled up on the calculator. So we need A and B. So let's go back over to the calculator. You should still have it on your screen. So A, let's go 2 places. So A is going to be negative 0.08 and B is going to be 2.68. And now we could put that together in the equation y equals A plus BX. So my equation is going to be y prime. Well, let's write down A. So A is negative 0.08. And we said B is 2.68. So then y prime is going to be equal to A, which is negative 0.08, plus B, 2.68 times X. So there's my regression equation. And let's plot it on our scatter diagram just so we could see the nice fit. So back to the calculator, press y equals, and let's type in that equation. So we have negative 0.08 plus 2.68x. And we had already pulled the scatter diagram up before, so now we just have to press graph, and this line will fit right over the graph. All right, so back to the question. So part E says, interpret the slope of this regression line. So the slope is B. So the slope in this case is 2.68, and I'm going to put it over 1. This way we could make the comparison and the change in units. And this always represents the change in Y with respect to the change in X, and Y is cholesterol. So this is going to represent the change in cholesterol with respect to the change in the amount of fat in the item, and cholesterol is in milligrams and fat is in grams. So what we would say is, because both are positive, right? So as one is increasing, the other's increasing. Well, at what rate? Well, for every 1 unit that the item increases in fat, so for every additional gram of fat, because that's the numerator, right, +1, we would expect the cholesterol to increase also because the numerator is positive and it's going to increase by 2.68 milligrams. So we would say for every additional gram of fat in an item, we expect the item to increase in cholesterol by 2.68 milligrams. So for every additional gram of fat in an item, we expect the item to increase also in cholesterol by about 2.68 milligrams. So that's the rate of change in this case. So part F says, let's use this regression equation to predict the amount of cholesterol in an item given the total amount of fat is 14 grams. So if X is 14, let's predict the amount of cholesterol, which is Y. So Y prime is going to be equal to negative 0.08 plus 2.68, but now we're going to replace X with 14. So we're going to input 14 into our regression equation and we're going to make the prediction. So let's plug into the calculator. So we have negative 0.08 plus 2.68 times 14. And we get about 37.44. And we're predicting the cholesterol, and the cholesterol is in milligrams. So it's going to be about 37.44 milligrams. Part G says predict the amount of cholesterol in an item given the total amount of fat is 35 grams. So in other words, what if X is 35? Then the predicted Y value is going to be equal to negative 0.08 plus 2.68 times 35. And we could plug that into the calculator as well. And that's about 93.72 milligrams. So last part of the question, is the predicted value obtained in part G an interpolated or extrapolated value, and why? So let's look at part G. We predicted the amount of cholesterol given the item as 35 grams of fat. So let's go back to the data set. Now, for the items that we studied, what was the fat range? It looks like the lowest fat content is 2. And the highest amount of fat in any item looks like 29. So these items ranged anywhere from 2 to 29 grams of fat, right? Now 35 doesn't fall between 2 and 29. It falls outside that range. So that prediction that we made, we're going to consider it extrapolated. So it's going to be an extrapolated value since x equals 35 falls outside the range of x values in our data set. So very similar to the last part of the question that we did in the previous video where I asked you to tell me if we had an interpolated or an extrapolated value. So this wraps up this last example. So we're done, with chapter 4. You'll have additional practice in my stat lab with the homework. In the next lecture, we're going to start chapter 5.